Thank you for your interest in Filtermatic's biological safety cabinets. Biological safety cabinets are amongst the most common and effective primary containment devices used in laboratories to protect individuals when working with biological agents. Properly maintained biological safety cabinets, used in conjunction with good microbiological techniques, provide effective containment for the safe manipulation of low, moderate, and high-risk microorganisms. Filtermatic's biological safety cabinets are designed to recirculate 70% of the air in a unidirectional manner across the work surface through HEPA filters, whilst venting 30% of the air to atmosphere through HEPA exhaust filters. The escape of particulate matter from the workspace is prevented by an inward flow of air through the front work access aperture. All internal surfaces are constructed from stainless steel. The base has coved corners around the perimeter to prevent contaminant buildup and ease of cleaning. The external components will be powder coated. The cabinet is pre-wired, energy efficient, and electronically ballasted. Excellent visual properties are provided to work safely. Biological safety cabinets are safety devices and are designed to protect the personnel and product. Low or no airflow conditions will create a safety risk, and as a consequence, state-of-the-art alarms are provided to ensure protection of personnel. South African Statutory Requirements, VC 8041. The Minister of Trade and Industry, Alec Erwin, amended the compulsory specification for microbiological safety cabinets on the 2nd of February 2001. Simply put, no person may import, manufacture, advertise, or sell as well as supply a service to which a compulsory specification applies unless he or she has been granted a homologation certificate or sales permit by the National Regulator for Compulsory Specifications, NRCS. Homologation number NRCS/8041/0002 has been awarded to Filtermatics, declaring their biological safety cabinet design and performance safe. Decontamination. Decontamination is performed to render the cabinet non-infectious and is achieved by exposing the work surfaces, exhaust filters, air plenums, and fans to formaldehyde or hydrogen peroxide vapors, for example. In 1987, the U.S. Environmental Protection Agency, EPA, declared formaldehyde as a probable human carcinogen. Formaldehyde is a cheap and effective method for decontamination, but is largely being discontinued throughout the world because of the inherent dangers to individuals and the relatively long time needed for effective decontamination. Hydrogen peroxide vapor, HPV. Hydrogen peroxide vapor is a sporicide disinfecting agent and effective for disinfecting all the internal surfaces of biological safety cabinets and any fixed equipment that may be in the cabinet, as well as the HEPA filters. When used together with peracetic acid and acetic acid, the internationally renowned MinCare product is created. This unique solution is diffused by a dry fog system, which generates a dense fog inside the hermetically sealed cabinet. The process converts the fog into water vapor and the decontamination agent into a gaseous state. After several minutes of diffusion, the fumes or fog must remain in contact with all the surfaces in the biological safety cabinet for 60 minutes to achieve adequate contact time. Once this has been done, the ventilation system may be restarted in order to eliminate the gas residue. MinCare is a full-range biocide agent which effectively destroys bacteria, yeasts, mold, myobacteria, bacterial spores, and viruses. CE medical certification has been awarded for effectiveness after testing to the American, AOAC, and European, EN standards. Preparing the biological safety cabinet for decontamination. The biological safety cabinet must be prepared carefully in order to guarantee optimum usage of the dry fog system and to achieve proper disinfection of the cabinet, its HEPA filters, and other components. Cleaning. The cabinet should be cleared of any items not vital for the disinfection process, and accessible surfaces should be cleaned with a gentle detergent compatible with the materials of construction of the cabinet. Chlorinated agents are not recommended. The clean surfaces should be rinsed and dried before disinfection. Air recirculation. During the disinfection process, the cabinet will be operating in full recirculation mode. If this operating mode is not already provided in the cabinet design, the manufacturer will have to provide a device in the top part of the hood to collect the air as it exits so that it can be circulated back into the cabinet. Airtight seal. During the disinfection process, the cabinet must be made airtight. The front window should be hermetically sealed. Devices may have to be provided by the biological safety cabinet manufacturer to compress against the glass to produce the best possible hermetic seal. If a hermetic seal is not possible, it will be necessary to cover the whole hood with a plastic bag to isolate the cabinet from the environment. Compressed air connection. Dry fog requires compressed air to operate. A minimum compressed airflow of 70 litres per minute at 5 bar is considered optimum. The specifications required for the compressed air will include clean dry air with an outlet to a sterilizing hydrophobic membrane. The compressed air supply will be located outside the cabinet, and a flexible hose will deliver the compressed air to the inside of the cabinet via a supply tap in the hood or via a connection in the cover plate. A manual valve on the compressed air supply pipe will enable the dry fog to be turned on or off from outside the cabinet. Measuring humidity. The disinfection procedure and efficiency is continuously monitored by relative humidity measurements. It is important to have a relative humidity sensor in the cabinet for these purposes. The initial relative humidity will be noted to calculate the quantity of water to be diffused for effective decontamination while limiting condensation as far as possible. If the humidity measurements remain stable during the contact phase, the cabinet is considered airtight and effective disinfection is being achieved. 3 phases must be observed. Diffusion. The relative humidity increases and must be between 70 and 85% at the end of diffusion. Contact time. The relative humidity must remain stable at between 70 and 85% for 1 hour of contact time. Ventilation. In extraction mode, the hood expels the fumes. The internal relative humidity should reduce until it returns to a reading that is close to the initial startup humidity. The disinfection process is then complete. The decontamination process can be conducted without evacuating the space, making dry fog the method of choice for decontamination in modern laboratories. Knowing the law. Legislation states that every employer shall provide and maintain, as far as reasonably practicable, a working environment that is safe and without risk to its employees. Filtermatics, a proudly South African company committed to earning your trust.